Have you ever wondered how your phone just knows exactly what video to recommend to you next? Or how a GPS can figure out the absolute fastest route right in the middle of traffic? Well, the answer is a word you hear all the time: algorithm. And today, we're going to break down what that really means.
Welcome to JASM Graphs. And trust me, it's a whole lot simpler and way more familiar than you probably think.
So let me start by asking you a kind of weird question. What on earth does a recipe for your favorite breakfast have in common with the social media feed you scroll through every day? The answer to that? Well, that's the key to understanding everything. And that answer is an algorithm. At its very core, an algorithm is just a set of rules. It's a step-by-step list of instructions designed to solve one specific problem or finish a task. Honestly, the best way to think about it is as a recipe. A recipe tells you exactly what to do, in what order to get a very specific result, right? An algorithm does the exact same thing, but it's for a computer. Here's the cool part. Every single algorithm, no matter how complex it seems, from just sorting a list of names to recommending your next favorite movie, is built from just 3 incredibly simple commands. So let's check out these basic building blocks. First up, we've got sequence. This is the most straightforward piece of the puzzle. It's just a series of steps that you follow one after another in a very specific order. Just like a recipe says, first mix the flour and eggs, and then next heat the pan. A sequence just makes sure tasks get done in a straight line. Simple as that. Next, there's selection. Now, this is where algorithms start to get a little bit smarter. Selection allows an algorithm to actually make a decision. It works on a really simple if this, then that, otherwise do something else kind of logic. For example, if the pancake is golden brown, then you flip it. Else, you wait another 30 seconds. This is what lets an algorithm handle different situations and go down different paths. And our third building block is iteration, which you'll also hear called a loop. And honestly, this is what makes algorithms so incredibly powerful and efficient. Iteration lets a set of instructions be repeated over and over and over again as long as a certain condition is true. So instead of writing add 1 cup of flour 10 times, you can just say, while the bowl isn't full, keep adding flour. It's all about automating repetition. Okay, so we have sequence, selection, and iteration. Now let's see how these 3 blocks can actually combine to build a real working algorithm. We're going to use a classic, super simple example: finding the largest number in a list. All right, here's the recipe for that. First, we use sequence. We just start by assuming the very first number is the biggest one. Easy enough. Then we use iteration. We create a loop to go through every single other number in the list. Now, inside that loop, we use selection. We ask the question, is this new number bigger than our current largest? If it is, it becomes the new largest. We just repeat this until we've checked every number. When that loop is finally done, whatever we're left with is our answer. This brings up something that confuses a lot of people. If an algorithm is a set of steps for a computer to follow, isn't that just a program? Well, not quite. Okay, this is such a great way to see the difference. An algorithm is the blueprint. It's the abstract idea, the logical plan that you could write out in plain English. A program, on the other hand, is the actual house you build from that blueprint, and it's written in a specific coding language like Python or Java that a computer can actually execute. So think of it this way: the algorithm is the strategy, and the program is the tool that actually carries out that strategy. And understanding that difference is so important, because once you have the blueprint, you can build all sorts of incredible things. This simple concept of a step-by-step recipe is the foundation for almost every single piece of technology we use today. And just look at their reach. Algorithms are the absolute heart of computer science. They're what powers search engines to give you an answer in milliseconds. They curate your social media feeds, deciding exactly what you see next. They're even the core logic behind really complex artificial intelligence and data science, helping us find patterns in just massive amounts of information. This quote really helps separate 2 terms that get mixed up all the time. An algorithm gives you the fixed set of rules for making a decision, like the steps we use to find the biggest number. Artificial intelligence, on the other hand, it uses that framework, but it also learns from tons of data to make smarter and smarter decisions within those rules. All right, that was a lot to take in, I know. So let's quickly recap the most important things you need to remember from all this. So if you remember anything, remember this: an algorithm is just a recipe. It's a set of steps. Those steps are built from 3 super simple ideas: doing things in order, making choices, and repeating actions. And this basic idea is the essential blueprint behind all the software that literally shapes our world today. So I'll leave you with a final thought to chew on. Now that you know the building blocks, just think about your day. Where else do you see these step-by-step recipes at work? From your GPS route to your music playlist, I promise you they are absolutely everywhere.
Hey, if you found this explainer helpful for understanding what algorithms are all about, please do me a favor and hit that like button, and maybe share it with someone else who might be curious. And of course, make sure you subscribe to Jossam Graphs for more breakdowns of complex topics just like this one.
Thanks so much for watching, and we'll see you in the next one.